Hello everyone, welcome back to the quotient property of radicals. If you've got a thinking hat in your room, put it on because we're going to need it for today. First step we're going to do when we're working with a fraction that includes variables with powers is we're going to split it up into the two separate roots. First rule for working with this is to simplify. And we're going to use yesterday's trick. If we have a power that the index does not go into evenly, we're going to work with that and rewrite it. So right now I still have the square root of y to the 8th, but I'm going to change this into the square root of x to the 6th times x. X to the 6th and an x still equals x to the 7th. Now I'm going to simplify whatever I can. So the square root of y to the 8th, it's like dividing 8 by 2. I get y to the 4th. Okay, square root of x to the 6th is the same thing as saying x cubed comes out. I cannot work with our x. Well, we are almost done. However, we should know by now, we cannot leave a square root in a denominator. It's a no, 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 okay? You'll be haunted in your dreams by square roots. Okay, so what we're going to do is we need to multiply the top and bottom by the square root of x. So as we rewrite our final problem, we're going to find our numerator is going to be y to the 4th times square root of x. Out of here is going to pop an x. So you really have, because x squared times x makes x come out, so you really have x cubed and an x. So I really have x to the 4th. Now, don't go all crazy canceling on me. Remember, this is in square root jail. He's untouchable by this guy. You may not cancel. This is the final answer. Y to the 4th times the square root of x over x to the 4th. Need to maybe double check. Okay, we had an even root. We had an even power, but it came out to be even. So we're good. No absolute values. And moving on. Again, split up your problem. 2, and that was a y cubed over square root of 5z. Okay, now if I could simplify it all, I'm going to look at the top and say, okay, I need to rewrite this guy 2 times y squared times y over the square root of 5z. As we simplify, I see the only thing that can be taken out is a y from here. 2 times y remains inside the square root of 5z on the bottom. Okay, I'm out of room, so I'm going to rewrite my problem down here. Just give me a moment here to gather my thoughts and redo this. Okay, why am I rewriting it? I don't like this in the denominator. This is a no, 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 no. So we're going to multiply it top and bottom by that denominator, square root of 5z. Now as we look here, on the bottom, when you take the same square root times itself, it makes that quantity pop out. So 5z will be our denominator. But up here, nothing will simplify. So my y remains on the outside, but an index. We multiply the constants inside, the coefficients. 2 times 5 gives me 10. And I just go y times z. Now, this is my answer. And did I have any even powers to start with? Nope. So I did not have to worry about it. This is the final answer. Okay, moving on. Looking up here, again, this time we're working with a cube root, so we split it. But now this is where you need the thinking hat. Because as I look at this, in order to make stuff come out, I have to have things written in thirds. I'm not going to be able to simplify this. But I don't want to leave a cube root. I don't want to leave any root in my denominator. So what I have to do is I need to multiply this by enough stuff so that I can take a cube root of it. So I'm going to take 1 minute and show you how I work this problem. I know that as I look at 9 is really the same thing as 3 squared. I still have my x. So I need to have 3 cubed and x cubed in order to apply the cube root. So I don't just come over to the side. I'm going to show you what you don't do first of all. I just don't come over to the side and do this, where I just rewrite it exactly as I see it, because now I would have 3 to the 4th and only x squared. I could take some 3's out, but I'd still be left with a 3, but I could take no x's out. So I would still have part of a cube root on the bottom. So this is what you do instead. You do a little exponent math. So if I look at this, I have a cube root. I'm still going to multiply top and bottom by a cube root. But how many more 3's do I need so that I have 3 cubed when I add the exponents? Well, I just need one more. So I'm going to write a 3, top and bottom. Now this is x to the first. How many more x's do I need to get to x cubed? Well, I just need 2 more. So I'm going to write down x squared. Okay, once I've done that, as I come and I multiply the bottom, I have 3 cubed, cube root of 3. Well, you know what? I'm going to back up, guys. I think I'm going to write it all out so you can see it. Let me write this down here. So as we come and we do this problem, so we have the cube root of 2 times 3, which is 6, x squared. Okay, I apologize for my horrible root symbol, my index, you'll forgive me. And on the bottom, I have the cube root of 3 cubed and x cubed. So when I look at my final answer, my numerator stays the same. Cube root of 6x squared. On the bottom, what's the cube root of 3 cubed? It's just a 3. What's the cube root of x cubed? It's just an x, because it was like saying I'm going to divide this index by a 3. Okay, we're working with an odd index, so we don't have to worry about absolute value. This is what we're going to do. Now, this is kind of a hard problem. Look in the example page. It's the second page into section 6-2. Look towards the bottom. There's some more examples on quotient product of property. If you struggle, come visit me in some office hours. Good luck and have a good day. Goodbye.